When we look back at the 1,000-ton stones of Baalbek, or the intricate bronze gears of the Antikythera mechanism, the sheer scale and precision of the engineering can be difficult to process. Because modern construction relies on heavy internal combustion machinery and computer-aided design, it is tempting to look at massive ancient megaliths and assume people couldn't possibly move them with timber and rope. Archaeologists refer to this cognitive trap as the out-of-place artifact fallacy. It creates an explanatory gap. Fringe theories and ancient aliens media exploit that exact gap, claiming that humans must have had extraterrestrial assistance to achieve such high tolerances. But modern archaeometry is taking a different approach. Using tools like electron microscopes, stable isotope analysis, and high-resolution CT scans, researchers are looking directly inside the atomic and molecular structure of these exact artifacts. The physical evidence they are finding shows that ancient civilizations relied on a staggering empirical mastery of physics, material science, and chemistry. We are only now capable of reverse engineering their methods. The Great Pyramid of Giza contains over 6 million tons of stone. Structures with this immense physical footprint make easy targets for alternative history narratives. The standard pseudoscience claim suggests that cutting and transporting these monolithic limestone and granite blocks over miles of rough terrain required levitation, acoustic resonance, or anti-gravity technology. The archaeological record points to a deep applied understanding of soil mechanics and dynamic friction reduction. Ancient engineers utilized extreme mechanical advantage, engineered ramp systems, and precise workforce coordination to defeat gravity. To navigate rough terrain, the Roman architect Vitruvius documented a specific logistical solution. Builders constructed massive 12-foot wooden wheels and locked the stone block directly into the center. The stone itself became the axle. Teams of draft animals could then roll massive columns and architraves across the landscape. They moved mountains of rock through calculated logistical engineering and physical leverage. At the opposite end of the physical scale is a device recovered from a 2,000-year-old shipwreck off the coast of Greece. For decades, the Antikythera mechanism presented a serious historical mystery. It appeared to be a highly complex analog computer, predicting eclipses and planetary positions, a level of mechanical calculation that does not reappear in Europe for another 1,000 years. By utilizing microfocal X-ray computed tomography, researchers virtually stripped away the calcified marine growth. Inside, they uncovered a system of over 30 precision-cut bronze gears. The designers even modeled the moon's variable orbital speed using an offset pin and slot configuration. A pin protruding from one gear slides back and forth within the slot of an adjacent gear. This systematically alters the output speed to match the moon's elliptical orbit. Hellenistic engineers successfully translated centuries of abstract astronomical observations into precise physical hardware. While Greek engineers built intricate kinematic gear trains, the Romans mastered industrial chemistry. The Pantheon's dome has stood unreinforced for 1,900 years, while modern Portland cement structures routinely develop severe structural faults within 50 years. Recent chemical mapping of Roman marine concrete revealed a deliberate hot mixing method. By adding unslaked quicklime directly to volcanic ash and water, builders triggered a highly exothermic reaction. This intense heat accelerated curing times and trapped millimeter-sized, highly reactive inclusions called limeclasts throughout the cement matrix. When seismic stress creates a microcrack, the fracture travels directly into these brittle limeclasts. Water seeps into the opening, dissolving the reactive calcium core into a saturated solution. This calcium carbonate immediately recrystallizes, autonomously sealing the breach before a catastrophic failure. This empirical mastery of chemistry extended to optics. The 4th century Lycurgus Cup appears green under reflected light, but glows ruby red when illuminated from behind. Electron microscopy shows that glassmakers added specific ratios of gold and silver to the melt. During a controlled high-temperature treatment, these metals formed colloidal nanoparticles measuring just 50 to 100 nanometers across, perfectly sized to scatter light in a process known today as surface plasmon resonance. Ancient pyrotechnologists lacked the theoretical framework of atomic physics, but they manipulated sub-microscopic metallic structures to build self-repairing infrastructure and highly advanced optical filters. Hundreds of years later, bladesmiths in the Middle East produced swords with extreme flexibility and edge retention. The surface of Damascus steel features a flowing, watered pattern, distinct from modern forge-welded alloys. The raw material was a high-carbon Indian crucible steel known as woots. Its performance relied on localized iron ore that carried specific trace impurities of vanadium and molybdenum. During cyclic, low-temperature forging, these trace elements acted as catalysts. The thermal cycles forced the impurities to segregate into discrete planes, nucleating the growth of multi-walled carbon nanotubes that encapsulated and protected brittle cementite nanowires. By relying on localized ore chemistry and rigorous empirical thermal cycling, ancient bladesmiths synthesized an advanced carbon nanotube composite matrix. The archaeological record shows that technological progression is a complex cycle of empirical optimization and regression. When trade routes collapsed, specific ore deposits ran dry, and regional stability fractured, the interconnected systems required to produce woot steel or hot mixed concrete vanished. The knowledge was lost to supply chain failure, not a sudden drop in human intelligence. Looking at the immense stones of Baalbek, or the precise gear ratios of the Antikythera mechanism, and attributing them to extraterrestrials ignores the physical evidence. It robs our ancestors of their ingenuity and their historical agency. By studying these lost systems with modern tools, researchers can reverse engineer highly durable, self-regenerating materials to improve our modern infrastructure. Which ancient technology surprised you the most, and what knowledge do you think humanity may have lost?